Good afternoon, friends. Let's start. Am I audible?
Yes, sir.
Yes, sir, you are audible, sir.
Yes. Is the presentation visible?
Yes, sir.
Yes, sir.
Okay. So we will continue on the discussions on UML diagrams. We have discussed about variety of diagrams, behavioral as well as structural. And in the behavioral category, we have seen the use case diagram, which is always the diagram to start with from the specification. Naturally, coming close next, which supports the use case diagram, is the structural class diagram, which you'll find very, very familiar to the notions that you have seen in C++ already. So let us, so this is what we have, the use case diagram. So we are still with the requirements model. In the use case model, we have use case diagram, and the problem domain model class diagram is what we are going to discuss. Let us. So typically, the class diagram again is not something unique. You can have a domain model diagram, or rather, in addition, you could have diagram of implementation classes. So it basically depends on the level of details that you are basically you are going to cover in that modeling. So it talks about the levels of classes and interfaces. It shows the features, the constraints, relationships like association, generalization, dependency, etc. So we'll see the notations for those. Now, in terms of features of a class, there are non-static features which are characterize every individual instance, and there are static features. You have seen this in C++. And in a different categorization, you have structural features which are called attributes, data members of C++ class, and you have behavioral features or methods or member functions of C++ class. Right. So now, a class is simply written by within a rectangular box with the name, the first letter of the name capitalized. So if you just write this, then it means a student class, but the details are not there. I mean, initially it could just be that. And an abstract class, which means something which cannot be instantiated, do not relate this. Mind you, do not relate this to existence of pure virtual functions and all that. Those are again C++ specific, interpretation, right? C++ specific semantics. Here you can explicitly say that a class is abstract, which means that you will not be able to create any instance for that. Right? Now, the class, as I said, will have properties. So the properties have this kind of a format. The feasibility is mentioned first, followed by the property name, then the type of the property. This is a data type. Then multiplicity. Multiplicity is square bracket. This is somewhat of a Backus-Naur format where the square bracket means 0 or 1. So you may provide multiplicity or you may not. Then default value, if there is any, and a property string, which is in curly braces, which means that it may be there. One property string may be there, or multiple property strings could be there, 0 or many. Okay. Now, visibility are of three kinds, as in C++: public, shown by plus, protected by hash, and private by minus sign. property name, if a property name is static, ordered, unique, optional, that is, optional means it allows null values, and it could have multiplicities. Now, a derived property is designated by a hash. So just look at the example, that's easier. So student class name colon string. This means that it has an attribute name which is public of type string. Similarly, plus date of birth colon date. So these are either already known classes, like string, integer, you'll assume they are known classes, or they are classes that are defined as a part of the class diagram. Roll number is a string, and within curly brace you put a property string unique. So you're saying that a roll number for an instance has to be unique. No two instances can have the same roll number. Then you have plus slash age. This slash means age is a derived property, which is an integer, which means that as such, you will not have a value stored here, but you will have some method which can be invoked to compute the value of this derived property. Right, as this, that's logical, because age is not frozen. It depends on the date on which you are doing the query. Then you have subject, which is of type subject, and you have multiplicity there provided, which is one dot dot star, which says that it can have one subject or many subjects. The methods are specified in a similar way: visibility, operation name, then the list of parameters with their type, and colon, return type, and a property string. The visibility is similar. Operation name is underlined if it is static. And if it is an abstract method, then it is written with italicized font. And return type is optional. And again, operations could be of various kinds, read-only, static, and so on. So for the student class, we extend the class diagram with the methods. So it's a record attendance has a return type bool and is a protected method. Right. So it cannot be used by anyone, but can be used by subclasses. Then get certificate is a public method which can get different and it basically gives you a list of certificates. Certificate within the multiplicity, you have a star, so it can give you list of certificates. But the certificates are unique and they're ordered. Right? There's a first certificate, second certificate, like that. Then you have a private change subject, which takes a subject, gives you a bool. Public calculate age, which gives an integer. So you can see that whenever you need this attribute, derived attribute age, you need to do the calculate age. Then that would be a public method, book music class slot, which is a bool. It's a concurrent. It's a concurrent method, which means that many instances could execute this at the same time. So from the LMS, these are some of the abstract classes. We can say the employee, the name, employee ID. Actually, by the side of employee ID, we should write unique. The gender, the Boolean on duty, salary, date of joining, reporting, and the following few public methods. Similarly, leave has a number of attributes like start date, end date, status, which can be new or approved. Is valid is a derived attribute, because as such you do not know whether it is valid unless you have performed a is valid method operation. Okay. So these are some samples of that. Let us look at a more detailed example. Say we are talking about a library. Let me show you the annotated diagram. Okay, first let us look at the non-annotated one. So this box say, the outer box say that it is a library domain model you are talking about, right? The class diagram of library domain model. And you have multiple classes, and for every attribute you have the types, like ISBN number is a string which is an ID. Name is a string, subject is a string. So that is how you describe a book. Similarly, you describe an author. You describe a book item. The book item differs from the book in the sense that suppose we say Principles of Compiler Construction by Aho, Shetty, Lamb, and Ullman. This is a book. Now, the book is a unique concept. It has a fixed ISBN name and all that. But the library will have multiple books. Right? Given a Principles of Compiler Construction, it will have multiple copies of that. Right? So it needs, besides the properties of the book, which is common, it needs to have additional properties for specifying each and every book. For example, it has a barcode, let's say. It has a tag, RFID tag, to uniquely identify that copy. It has ISBN number, which is hat. Hat means that it is a property from the parent class. Because certainly all of these books will have the same ISBN number, same subject. So this is there's a title, the reference type, language, etc. And then you have a number of derived properties: loan period, due date, is overdue, because these properties for any specific copy of the book will depend on the borrowing and returning characteristics of the book item. Similarly, you have authors, you have name, the biography, birth date, you have all these different address, full name, language, account state, format. These are all different classes, some of which may be used in defining the, for example, the account state is used in the account class for defining the state of an account. So here you're saying that account class can have three possible values. It is an enumeration class. So it just enumerates possible values. Similarly, language, if you look at the book item lang, you have language. So this is one of these languages, and so on and so forth. Then you have the library itself. The library has a catalog. Then you have patrons, basically users, and the librarian who manages, patron who just searches. Every patron has an account. Right? So this is kind of the broad diagram. Let's come to more specifics of what different things mean. So book is an abstract class. Why? We have not written abstract, but we have written the name in the italicized form. As I said that, abstract methods are those which are written as italicized. Similarly, if the class name is written in italics, then it's an abstract class. This is 0 to 1 is multiplicity, which says that there could be an ISBN number or it could be missing. 0 means there's no number available. Book item, similarly, it is a stereotyped class. This is a generalization, is a relationship which you are familiar with. Then let us look at other relationships. We'll talk about these more later, but let me introduce here. So these are like these links are called associations. So these are all different associations. In this association, two or more classes, but more typically two classes, get into a relationship. So he said this is relating author with book. And the name of this association relationship is wrote. And then this arrow denotes in which order you read this relationship. So here the arrow is from author towards book. So you read it as author wrote book. So that English sentence is nicely. And then at both ends, you have multiplicities. Multiplicities tell you how many entities or how many instances of a class can be related to how many instances of the other class. So here you are saying, so understand what one dot dot means and one dot dot means. See, one dot dot star means any number, more than one. So one dot dot star means that there could be multiple books, right? There's a multiplicity of more than one. So an author would have written multiple books. And it says on this end also, it says it is multiple. So that means that a book may have been written by multiple authors. So an author can write multiple books. Model to this nice piece of the diagram. Right? So this is one kind of association. Account is an account in the library. Right? So a user is a patron who has an account. We'll talk about this nature of association, the account nature of association little later. But you have an account here. So account has these are the attributes. You have number, you have history, the ID number of the account, when it was opened, what is the account state. So it relates to the book item, because certainly you cannot borrow the book as such, because it's an abstract concept. The physical books, the copies can be borrowed. So the reading direction is from right to left. So it reads account borrowed book item. Account borrowed. So this says that a person, say PPD, borrowed principles of compiler construction. Like that. On the account side, there is no number mentioned. If nothing is mentioned, it means one. And on the other side, there are numbers, a range of numbers given, which is the multiplicity 0 to 12. So this models that account borrowed 0 to 12 books, which means that the account may not have borrowed any book. Can borrow one book, two books, maximum up to 12 books. So that gives you the kind of what is the allowable number of books that you can borrow at any point of time, right? So this information is encoded in this way. But no book can be borrowed by two accounts at the same time. So here it is one. Every book has a fixed borrower. Then you can reserve books also. You can say that a book is you want, you don't get it. So you say, okay, I'm reserving it. So as soon as it is returned, I should be able to borrow it. So you reserve the book. So account reserved book item, and you are allowed to reserve up to 3 books. So that is what this is saying. Right. So these are the simple relationships. Then you have relationships of the kind where at one end you have a diamond. open. So this kind of a relationship is called an aggregation relationship, aggregation association. What does that mean? Let's say I have a library. The library has to be unique. Central Library of IIT Kharagpur is unique. And it has accounts. So it will have multiple, several users, and they will have accounts each. So the library has account, and there's one library, and it has 0 or more accounts. Okay. Similarly, there is one library which has 0 or more book items. There is one patron which has one account. That is, every patron must have an account. And otherwise, the person is not a patron. In contrast, we say that the library and catalog are related by a similar kind of association, which is known as composition, and denoted by this filled-in diamond. So library has a catalog. Now, you will certainly get, you will certainly feel that what is the difference? What is the difference of doing an aggregation? Library has accounts, library has book items, and library has a catalog. The difference is when you say it is a composition, then it is a part of the bigger concept. When you say it is an aggregation, then it is not a part of the bigger concept, but it is just associated with that concept. Right? So let me tell you also from a different domain. Suppose you think of a car and you think of wheels. Now, the car, the wheels are part of the car. Right? If you take away the wheel, the car does not exist. So it is a composition. Right? Car is composed of the wheels. Similarly, the steering wheel, the windshield, the air conditioning, everything. Those are all compositions of the car. But if you think about the owner is an aggregation. The dealer is an aggregation, or the service center is an aggregation, because they are related to the car, but not a part of the car. If you take away the owner, sell the car back to the, first buy service or OLX or something, then the owner can change. A car may not have an owner at a given point of time. That does not impact the car by itself. So these two, aggregation and composition, are also known as aggregation. Often is referred to as weak aggregation. That is, these are aggregations which are relationships but not strongly component of the primary concept. Whereas composition is known as a strong aggregation, because without that you cannot define the primary concept. So you cannot define a library without a catalog. Library must have. Okay. So that is a composition. Composition catalog in return is also related to, associated to records, to book items through an operation of catalog records book item, where there's only one catalog and it has multiple instances of books. Then when the reading direction is not specified as in here, then it is typically from the unitary multiplicity to the other side. So we'll read this as catalog records book item. Right? So these are then there are others like the catalog has different interfaces. Like what is a catalog? Catalog is a kind of a database. Now, what can you do with the database? You could search by title, search by author, search by ISBN number, and so on and so forth. So there's an interface of search. Similarly, there's an interface of management. Management is when you purchase books, you add it to the catalog. When a book gets lost, gets destroyed, you remove it from the catalog, and so on and so forth. So there is this is another interface. So interfaces are also special type of classes which are written with the word interface within the Guillemot to show that they do not give you the implementation details, but they more talk about the functionality. And then this dotted dashed arrow with an inheritance kind of symbol, triangle, open triangle, is basically the interface realization. So these are the interfaces and they are realized by the catalog. That is different from the easy relationship, generalization relationship, where you say that the abstract concept book is specialized by a book item. No, here you are saying that these are kind of interfaces, abstract operations, and they are realized with this catalog. Then there are other kinds of dependency relationship. Here, you typically, if you have a dependency relationship, then you do a dashed arrow with the arrowhead, which is open, not triangle like this. And the type of dependency is specified by the name within the Guillemot. So you say patron use interface search, librarian use interface search, as well as librarian use interface manage. Account use account state. So you can see that the dependencies could be of various types. Here the dependency, the usage dependency is in terms of if I talk about use case diagram in terms of an actor and an item, but here between account and account state, it is basically the dependency between relationship between two classes in terms of one using the instance of the other class as a part of it. Right? So this is broadly just a quick overview of the kind of things that a class diagram could specify.
Sir?
Yes.
Sir, in that diagram, can we say that a catalog is an attribute of the library class?
It is not an attribute. Catalog is a class by itself. Catalog is a class by itself. Think about the catalog. Catalog is a list of book items that you have. Right. So it has information, certain information which is important for the management of the library. So it will have the tag, the title, the author, the year of publication, subject, this kind of, and there are entries of the book items in that. So it is truly a catalog. It is like a khata, so where you write down everything. Right. So that cannot be an attribute of library. I mean, you can always say that I have a book item as an entry and a catalog is an array of book items. You can do that kind of a modeling, but that will not be very appropriate because then everything that you need to do with catalog, those methods will become part of the library. Then library will have to provide a search, which is not intuitive. Library have to provide a management, right? Because the whole list is a part of the library as an attribute. Are you getting the difference?
Yes, sir.
For example, think about a car and a wheel, right? Just a very similar scenario, a car and the wheel. Now, wheel is a different class. And we will say, in terms of multiplicity, car is composed of n number of wheels, whether it's a two-wheeler car, four-wheeler car. So let's say four-wheeler car. So car is composed of four wheels. But then every wheel will have its own attributes. What is the diameter? What is the type of the wheel? Whether it has a tube or a tubeless wheel, or it is what is the make of the wheel, etc. May be different for different. For example, the current wear and tear status of a wheel can differ between the four wheels. Right? So it is while it is always possible to say that car has a attribute wheel, which is an array of four such entities. It is not a very nice way of modeling because it's a distinct concept. This has its own attributes, own operations, and own requirements. Right. So it is always good to show these concepts, which are complete by themselves, as different entities, and they may again have a different relation. For example, here catalog does not have a generalization, specialization kind of relationship. But if I talk about wheels, it will have that. Because in general, wheel is a concept. Then you have wheels of different types, tubeless, with tube. You have, it depends on the road grip, rubber, and all that. So you could have the different classification of hierarchy of wheels. And a car associates with, car is composed of instances of certain type of wheels. Right. So all this information will get lost if you start making the parts described within itself. Right. Are you getting the point?
Yes, sir.
Okay. Any other question? Okay, let's keep going. You ask. So I have already talked about this. I'll quickly browse through. So you can have associations. Let's keep this. So association typically this is the hierarchy of the association. So you have association, you have binary association, you have n-ary association, and in terms position, as you have seen. And a class may have association to itself. So this we have just discussed. So the association ends, the two ends, the navigability, in which way you go, and the association arity is a multiplicity. So it says that the professor wrote 0 or more textbooks. And his role, here you see two more annotations coming in. It says that this is maybe certain further annotation property that you want to attach, that whether the professor is an author or an editor or a curator of the book, and whether the book is a textbook or a reference book, and so on. So associations we have seen. Navigability also we have seen, how you can go from one to the other. And there are different forms of navigation that are possible. Like if you do not have an arrow, it means that nothing is specified. This is one directional, that is you can navigate from A2 to B2, but not the other way around. Right? So these information, navigability information, are very important in terms of forming the queries, because this will mean that given A2, I'll be able to find information about B2, but not the other way around. Right? So that's what you're capturing here. Here you're saying that A3 is not navigable from B3, but B3's navigability is unspecified. That is, you have not been able to resolve. On the right side, this says A4 is not navigable from B4, but B4 is navigable from A4. This is both way navigable, this is not navigable, and so on. Now, in general, associations will have arity, and binary associations are, as I said, is the most common. So we have seen this. An n-ary association typically is written in this form. If you have a diamond and you connect multiple classes through this diamond, and naturally, if it's an n-ary association, then you will give a common name to that association. So car is associated with the design bureau and year through the association design. Let's skip healthcare. You will find the domain more difficult. These are all. So weak association or weak aggregation, as I said, is a hollow diamond. So it's a triangle and we have segments. So this is not like three sides form a triangle. This is just segments. So you on the plane, you have thrown a set of segments, right? And three segments could form a triangle, which are called its sides. So three segments that form a triangle are the sides of the triangle, and segments could form multiple triangles. And any segment could be part of no triangle, one triangle, several triangles, and so on. If you want to uniquify, then you can say that this is 3 unique. That is, triangular sides collection of 3 unique line segments. That is, no line segment can take part in forming more than one triangle. And you're also saying that line segment is navigable from the triangle. Which is, given a triangle, I can find out which are the segments, but not the other way around. Okay? A strong aggregation, as we just discussed, is composition where it's a part of. So we have folder contains files. So file as a parent is a folder. There could be multiple files, but there'll be one folder. Okay? And you can see we were mentioning that a association could be to itself. So you could have this contents relationship between folder and folder, because a folder can contain other folders. So this just says that 0 or more files can be in a folder. Similarly, you can just loop back and say 0 or more folder can be in a folder. Right? So these are all different modelings. So with that, I think this we have already explained pretty much. This we have explained. So we are done with now generalization. You understand the generalization of classes. You have done that in C++ itself. There could be multiple inheritance also. I can have employee, temporary employee, permanent employee, consultant. So these are all easy relationships which are drawn in the same way. Then we have dependency. I mentioned about the dependency between catalog and the search interface. So dashed line with an open arrowhead. Then we can have constraints. Constraints are tagged to one class or It could be tagged with relationships also. So it is a relationship between vendor and stock. Stock purchased from vendor. Any number of stocks can be purchased from any number of vendors. But the constraint is, there is a constraint on the vendor that vendor should be listed in NSE, National Stock Exchange. I have a regulated water cooler, and the heater activates the regulated water cooler. Cooler activates the regulated water cooler. So it's a water cooler which can heat up the water as well as cool the water. But I want to specify that it cannot do both at the same time. So it said between these activates, I have a constraint XOR. And this, small dotted lines mean the constraint. So it says that heater activates or cooler activates cannot happen at the same time. Only either this has to happen or that has to happen. So these are the kind of constraints you can have. These are all done. We have all seen this. So if we think in terms of the leave hierarchy we talked of, now we have a better UML class diagram. These are different types of leave classes, and these are different abstract concepts. We talked about this earlier. Personal paid leave, certified leave, uncertified leave, post facto leave, no club leave, and so on. So this hierarchy is built up, and all of them then specialize from the abstract leave. The leave record is a weak aggregation of leaves. It's just a collection of leaves. And leave record has a documentation. Right? It may have documentation. And documentation, a part of documentation is a certificate. So this is about modeling the maternity certificate or parenthood certificate and so on. And then you have the hierarchy of different employees. You have relationships of reporting. An executive reports to lead, but no executive reports to more than one lead. Similarly, from lead to manager. And then executive is a specialization of the abstract employee who can approve a leave, because the abstract employee could be a lead or manager, can request for a leave, any number of, and you can consult a doctor who in turn issues a certificate. So this is how you complete your class diagram more and more. Any questions on the class diagram? Okay, then let's move to sequence diagram, which is a behavioral diagram. I told that sequence diagrams basically talk about the temporal ordering of things happening. So two main things in the sequence diagram, or three main things in the sequence diagram, are lifeline, messages, and interaction fragments. So typically works in the client server model, occurs here in the analysis phase and part of the behavioral model. We have seen all that. So the first thing is a lifeline. Lifeline is an element which represents an individual participant in the interaction. It represents only one interacting entity. Though typically lifelines will be named by classes, but we'll see that specific ones can be. So This is how you refer to a lifeline. Object name, we are talking about a specific instance, colon class name. If the object name, if the objects are an aggregate type, so it's an array of users, then you can also specify the selected from that aggregate. So these are lifelines. This says data colon stock. So the object data of class stock. This is some anonymous object of class user. This is k selected object X from class capital X. And what drops down is basically the lifeline, the existence of this object in the system. Mind you, we are now talking about behavioral diagram. So we are talking about the temporal aspect. So now we just only do not have classes. We have the instantiated objects which exist through the system. Let me go to the next. The second is there are messages. That is, one object can send a message to another object. A message is like a service request. You request another object that please do this for me. Then that receiving object, receiving lifeline, will try to serve that request and return you possibly an acknowledgement. So there could be typically two types of messages. One is action type messages. That is an operational call or start of an exit. Or it could be the presence of an event. Some event has taken place. Right? Let's see. So in the action type, you have various kinds of actions. You can have synchronous call, asynchronous call, create, delete, reply. Better to see. You have a web client. Say the Chrome browser is a web client. And you have an online bookshop. Let's say Amazon. Now, in a session of Chrome, what do we do? At some point, we send a request to search the online bookshop. This is called a synchronous call. Why synchronous? Because when I send this search request, whatever I was doing here, this is the execution block. Whatever I was doing in that tab of the Chrome browser, that action stops and the action to search starts. So this is called a synchronous. The other is called the asynchronous call. It's a service to task. The simplest way to look at asynchronous call is like you have composed a mail, and then you say send. Now, once you say send, you have sent this request, but you do not stop after pressing send. You can continue to read other messages. You can continue to compose another message, and so on and so forth. Okay? So, in the synchronous call, the sender waits for the recipient to act and respond. Whereas in an asynchronous call, the sender will proceed immediately without waiting for the completion or return value from the requested object. Right? The difference you can see in a synchronous call, the arrowhead is filled. In the asynchronous call, the arrowhead is open. And there could be specific actions by action types of messages, like create message, that you want to create an object. For example, in Amazon, you are registering and opening an account. So create an account, particularly shown by hashed line. You can see that this is in line with the asynchronous call. You can have a delete message, destroy. Say you want to delete the account, so you send a destroy message, which is this cross below the lifeline of account tell you that after this, the account ceases to exist. And you can have reply message. Reply message is when, particularly in a synchronous call, when you send a request, you are waiting. So how long would you wait? So for that, the online bookshop has to send a response back. It does the search and all, and then it sends a response back. That is a reply message. And that again is asynchronous from the perspective of online bookshop. That is, after sending this, the online bookshop continues doing whatever it was doing. It does not wait again for your response to that. So it has got a request, it has responded to that. Right? So this is the simple interactions. The other kind of messages are based on the presence of events. Let's say, for example, a message may be lost. You tried to search, it did not give you anything, 404. So there's a lost message. There could be a found message that the online bookshop gets a search request, but there is no known sending event. So you model it. Right? I think be able to understand this. So there's a window. These are the lifelines. So window, the JavaScript, the Ajax proxy. These are the primary lifelines. Now, window, there is a gating, some gating. When validated, the window gets a validated message. To start the validation process, window starts the validation process. Does some initial things like takes your user ID, password, all that. And then passes this on to the JavaScript to actually do the validation. So it sends another validate request to the JavaScript object. For doing that validation, the JavaScript, you're logging in, so the JavaScript has to create a session. Right? So it does create a proxy. Using Ajax, creates a proxy object, which starts working. And after sending this create, it activates the Ajax, and the create was asynchronous. So it does not wait for a response. After some time, it sends a asynchronous message to the proxy, the Ajax message, as to what all that need to be. In the meanwhile, the window had been waiting because it had given a synchronous call. The JavaScript is working. The JavaScript finished doing all this validation, returns with the reply. The Windows can proceed again, build some messages to respond to and so on, and reply back against this validate to the gate from where it got in. So there is a synchronous message here, there's a return message here, and these are all different execution specifications that are. Then it may be that the Windows needs some resting time, because it has to wait for a certain amount of time for maybe more data from the proxy to come back. So proxy sends that data by a callback, and meanwhile the Windows keep on sleeping. Then the Windows another execution specification starts, and it will, at the end of it, it gives an interaction. And so this is kind of, meanwhile Ajax can in turn send a Ajax request to the servlet, and that servlet continues, but if it has got an error, then it will get back to you destroying that servlet object. So this is the I have given other simplified login sequence diagrams also. This is a sequence diagram for placing orders. So there's a person, there's a product, there's a session manager, there's a shopping cart, then the cart item, the order, and the customer. So I will leave it to you to go through these lifelines and messages to understand how the entire order processing that we do. We all know what happens, but how to document it in an unambiguous, crisp form is the sequence diagram. So this, from the sequence diagram, you will clearly be able to specify what is happening on whose initiation and who is waiting for whom, what happens in an error, everything of that. And this is an authentication diagram from Facebook. Of course, this is an old authentication and is now. So I think this is time. So let me stop. If there are quick questions, I can take that. Any questions? No. Good. So any question?
So Professor PPT, this is Shorangshu.
Yes, Professor.
Just one thing. Just maybe, do you want to make the announcement regarding the test, or?
Yeah, we can, but there is only 15 people present. So the scheduled test will be on 8th April from 8 to 10. That is as per the central guideline given to us. So please be ready for that. The modalities, details, syllabus, breakup, forms of questions, all these we will come up to you very soon and give you those details. But the schedule according to our class slot, we are in slot E. So the slot E is scheduled for 8 a.m. to 10 a.m. on 8th April. That is Friday after the next. So please be ready for that. Okay.
Also, just, is there anybody here who has opted for an offline exam?
The probability is low.
Yeah. Okay.
Okay then. Thank you very much. See you tomorrow again. Have a nice day.